morning. So the others, please wake up. So we start the lesson already. Okay, now please see take out the notes. Now today the notes should be 3.4. So 3.4, I want the notes. Tutorial still not yet. Tutorial should be the next lesson. Okay, so hopefully the others, okay, join the link, then just go in. So I want to show the notes now. So everybody can see or not, please respond. Okay, please respond to me, you can see or not. Okay, now I just see the Justin got 3 participants at the teacher. Okay, now we coming soon already. So we still got 3, 2, 1. Okay, so now we start already. Okay, so from here, good morning, William. Okay, so we can start now. As soon faster wake up, don't be so tired. Okay, so now we start already. Okay, so wait a while. Okay, I'll go to off this one first. So the others ready, Okay, so I will see your comments. So for your name, please register there. Okay, register, just write your comment, then I know your name. So we start the lesson. Okay, let's see the notes. Transformer 3.4. Okay, so the first part we need to go is a function of the transformer. Okay, transformer is an electrical device which increase or decrease the alternating voltage. So this one is a function. So the first step, we're going to see the function first. They can using to be increase and also can be decreases the alternating voltage. Okay, so this one is a keyword, alternating. So we're using alternating current later. Okay, another thing, the transformer, they work based on electromagnetic induction. Remember, this one is what we learned during the 3.3. That means using the motion, then after that we generate the electricity. So this all, let's call it induced current, is it? So transformer, they're using this concept. They're never using any battery to generate the electricity. But memang when starting got lah. When starting they got using the alternating current first, then later another core, they will create the new current. They want using the electromagnetic induction. Okay, let me see the definition first. Okay, I'll show you the definition. Okay, let's see the definition for transformer. Electrical device which increase or decreases an alternating voltage based on the principle electromagnetic induction. Suppose they just join just now the 2 sentences. Okay, make it become 1 sentences. So this one we call it transformer. Okay, then we go to our lesson again. Okay, let's see the notes, the structure. Okay, I want to introduce a structure. Okay, let's see the first part. This one is the structure for the transformer. Can you see got 2 coil here? Okay, 2 coil. Okay, 2 coil. Okay, this one turning we call coil. Okay, so can you see the first part? This part later we will join with the power supply. The power supply must be alternating current. Okay, we can say alternating voltage. So this one should be the output. So I say we're using the electromagnetic induction is this part. Okay, I never said this part. This part they're using battery already. So that means this part actually they don't have any battery supply, power supply don't have. But later, the primary part, they will send, they will link the current go to output. Okay, so another one we're using the soft iron. Soft iron core, everybody know. Soft iron core, the reason is easy to magnetize and demagnetize. So this one later we learn more detail for the AC part. Okay, this one is the symbol for the transformer. Can you see they draw the turn? The turn is represent the number of the turns of the wire. Then center, they got 2 lines. Okay, so can you see the turn is a different? Okay, turn is a different, there's another meaning. Means later you got step up or step down transformer. If normal, the turn must be equal. Okay, so this one is a symbol for the transformer. Okay, now we're going to see the transformer structure. Okay, first one. The coil that connected to the input voltage we call primary coil. So this part is a primary. Okay, the coil that connected with the output we call that a secondary. So another one, the purpose. Okay, now they say the purpose of the iron core is provide the magnetic field linkage in the secondary coil. So the iron core at the center actually is for what? They want to link the magnetic field to the secondary coil. Okay, now we're going to see the symbol. Okay, IP represents primary current. IS represents secondary current. Then VP is a primary voltage. This one is a secondary voltage. So N is a number of turns. Okay, number of turns. So P is represent primary. Then another one S is a secondary lah. So this all thing we're just using the P and S to represent. Okay, now I'd like you to see one of the transformer structure. Okay, let's see this one. Can you see they got so many layers? Okay, transformer suppose this one layer. Why we need to do become the layer? Layer is later we will explain they can reduce the energy loss. Okay, if not layer, that means the whole thick bar, you find it the energy will lose faster. Okay, later we need to explain. So I just want to tell you this one layer, later another name we call it as a laminate. Okay, laminate layer. Okay, then after that this one same lah, this one is a transformer symbol. Okay, so there's a number of turns is the same. The common one, there should be the turning. Can you see the solenoid turning? That one should be the equal of the turns. So this one is a transformer symbol. Okay, we go back to this, see how the transformer working. Okay, this one can come up for the process question. They ask you, please explain the operating of the transformer. So from here, we're going to see how to work. Okay, first one, transformer work, you must mention. Okay, they're using what principle? So this one is the number 1. Okay, number 2, okay, now we're using AC, is it? When AC voltage you supply to the primary coil, what happened? The current, alternating current, they will flow in the coil. So we call it that's an IP. Okay, when the current just flow into a soft iron core, what happened? They will magnetize. Okay, magnetize become electromagnet lah. So from here, the magnet, this one, I underline already. So make sure you take notes. Okay, this one. The magnet produce various, okay, in magnitude and direction. Various means so many, different. Okay, why got various? Because you're using alternating current. Alternating current means you in, out. That means opposite direction. Because of this one, in, out, you produce value of the magnitude. After that, and also direction. Because of this one, different magnitude and direction, you find it that causes changes magnetic flux. That means normally we learn electromagnetic induction, we're using the motion, is it? We're using the hand to shake the wire. So you shake the wire means you up, down, actually you are changes the direction. So that means now we no need to using the hand to up, down. We're just using the alternating current. So I find it, the direction keep changes. So this one will create the changing magnetic flux at the soft iron core. So from here to pass through to the secondary coil. Okay, they got changing flux through the iron, soft iron. After that, they straightforward pass to the secondary coil. Finally, what happened for the secondary coil? They get induced EMF across the secondary coil is produced. So induced, we still got the word induced because you not generate by yourself. So this one we call induced. EMF means the voltage. So from here, the secondary coil can get the induced current. Okay, so this one is a working of the transformer. First one, you mentioned that using what principle? Number 2, alternating voltage you supply to the primary, then the alternating current will flow through. Okay, number 3, soft iron core that will magnetize. Okay, number 4, important. Now the magnet, they will produce a various magnitude and direction. Then after that, this causes changing magnetic flux through secondary coil. Finally, secondary coil will get induced EMF. So this one is a transformer, how to work. Okay, then I need to continue. Okay, this one question normally they will ask why we cannot using DC. Okay, I'm going to check attendance first. Okay, Melody, Derek, Guan, Yong Eun. This one already in already. Asun, I never see Asun name. Where's Asun got? Okay, a nurse. Until Melody stop already. So the others continue. Okay, so from here you see DC. Just now I said why DC cannot apply. Okay, let's see the DC. DC is a direct voltage. Apply to the primary coil. Okay, when I just apply to primary coil of the transformer, the output voltage secondary coil becomes 0. Okay, that means the output nothing can be get it. Okay, reason, because the magnet produced in the soft iron coil is what? Okay, can you see? This one, there's a constant magnitude and direction. Just now is what? Just now is various magnitude and direction. So this one you produce a constant because you always go to the same direction. Go to same direction, that means you cannot produce what? Cannot create the changing magnetic flux. Just now you can create because you keep moving in opposite direction. But this one, when you just go to same direction, actually you cannot create the changing magnetic flux. To where? To the secondary coil. Okay, so you just answer they produce a constant magnitude and direction. Do not create the changing magnetic flux. Finally, the secondary coil cannot get the induced current, is it? So from here they say, therefore, magnetic induction does not take part. Okay, they do not happen the electromagnetic induction. So this one is the question they will ask, why transformer must using alternating current voltage. Okay, so now we go the others. The second one, there's a structure of the symbol and also symbol of the transformer. Okay, we got two types of the transformer. Okay, let's see the first one. I show you this part is a step up transformer, up. Okay, when you see the word up means finally they will grow up. Okay, so that means input small. Okay, after I put the number of turn of the wire, output will become big. This one called step up transformer. That means later the output you get high voltage. So we say step up. Okay, how to control? Control by using the number of turn of the wire. Okay, so you can see this part got 3 turns only. This one got 4 turns. So that means the output, the voltage later should be higher than the input. Okay, now you can see drawing the symbol. Okay, the symbol, can you see the number of turns for the primary become less? The number of turns for the secondary become higher. So this one is a step up. Okay, so this one, I make sure this one we need to draw is a full line. Don't skip the line. Okay, we draw the 2 straight line at the center. This one is a step up transformer. Okay, now we're going to see the step down. Step down just terbalik. Can you see the primary coil? Okay, the first one, primary coil become more already. The number of turns of the primary coil increases. Number of turns for the secondary less already. So this one we call step down transformer. Step down transformer means later your output voltage will become drop. Okay, compared to the primary. So now when they draw, okay, also same. This one draw 2 lines, 2 straight lines. Okay, this one is a primary, this one is a secondary. So primary, the number of turns is more than secondary. So this one is a step down transformer. Okay, now I show you the structure. The diagram, more clear diagram lah. Okay, let's see here. Okay, this one is a number of turns, orange color one. That's a more clear. So you can see the secondary coil, the number of turns is more than the primary. Okay, so this one is a step up. Okay, another thing I want to see the graph. Okay, first part, can you see the graph? There's an alternating current. Can you see up and down? Okay, after pass through this transformer, you find it still up and down. There's still AC, but the problem, can you see the amplitude? The amplitude already increased. Amplitude stands for voltage. So that means now the output voltage after pass through the transformer, you find it the voltage increase already. So this one we call step up transformer. Then you can see the symbol also. The symbol primary they draw less. Then the secondary the turn they draw more. Then the center still two straight line. So this one we call it step up transformer. Function to increase output voltage. Okay, then I need to show is step down lah. Okay, step down. Okay, let's see the differences. Step down, just a number of turn you changes. Primary now the number of turn is more. Secondary now the number of turn become less. So let's see the graph also. When starting alternating voltage, so you find it the amplitude should be the higher. After pass through step down transformer, you find it the output voltage amplitude become less. Okay, but there's still alternating voltage. So when you draw the symbol, you just draw the primary become more turns, secondary become less. Okay, just like this only. So this one is a two type of the transformer I want to introduce. Okay, then we need to go to the next part. Okay, let's see the next part. Next part should be the conclusion about the step up and step down. Okay, let's see the step up. Step up is the number of the secondary more than the primary. Okay, step down means primary is more than the secondary. Okay, voltage also the same. Secondary more than primary for step up. Step down, primary more than secondary. So I can say, suppose voltage, there's a directly proportional with the number of turn. You can say when the number of turn increase, the voltage also will be increased. Okay, directly proportional. What we can control, we control the number of turn. Okay, for the secondary coil lah. Okay, voltage we cannot control for the secondary coil. We just can control for the primary coil. So number of turn both sides we also can be controlled. But the output voltage we still don't know. Later we need to count. Okay, another thing is the current. Okay, current is terbalik. Can you see this one secondary is more than primary, but the current is IP, primary more than secondary. Okay, why? So we're going to see this formula. Before that we got learned P equal VI. Okay, now we're going to see the power become constant. When the power step up and step down, the power become constant. So you find it when the voltage you go to increase, suppose the current will be decreases. So V and I actually is inversely proportional. Okay, when I say the Vs bigger than Vp, so your current should be reverse. The I primary more than the secondary. Then you can get the power become constant. So this one situation later we will explain what situation is the power become constant. Okay, that one should be the ideal transformer. Later we will introduce the ideal transformer. So when starting we just learn these two first. Okay, so the example where we're using step up for the transmission, power transmission, and also the EHT, extra high tension, we're using the step up transformer. Okay, step down we're using for the lab rotary and also used for the radio. Okay, example for your house, the TV, the radio, the computer. Okay, you're using your current in your voltage in your house is too high, 240 volt, but the others cannot support. So from here inside the laptop, inside your radio, TV, must have the transformer to reduce the voltage. Then after that they can be function. Okay, so this one we call step down transformer. Okay, let's see the relationship. Now we start with calculation. Okay, let's see the calculation. Okay, we're going to see the relationship first. Okay, number of turn. Okay, number of the coin we're using the N. Okay, another one should be the voltage in the transformer. Both become directly proportional. So if I ignore the symbol, you find it there's a K, and is it K is what? Constant number. You can say gradient. Okay, now we need to create the formula. Okay, example, I'm going to draw the graph. Okay, V versus N. Okay, so from here, there's a directly proportional. Okay, I want to find one of the point. Okay, so this one I label as a V1, this one as a N1. So gradient, how you find it? The gradient is V1 over the N1 lah, is it? So the second point, okay, I get it here. Okay, the second point, there's a V2. Okay, another one is a N2. So how you find the gradient? The gradient is V2 over N2. Okay, both gradients should be the same. So from here, I can create the formula is V1 over N1 equal to V2 over N2. So this one is what formula I want to show you today. So 1 stands for primary lah, 2 stands for secondary. So this one is what I prove it. Okay, you also can change become using this formula. Okay, you can make the Vs at the top, then the Vp you move another side, then the Ns you get at the top. So you become Vs Vp equal Ns Np. Okay, if you put the S at the top, N also must be secondary at the top, primary at the bottom. So depend for you which one formula you want to use. Okay, which one easier for you to memorize. So from here, I will prefer using this part. Because when you're using the V, bottom also is a V. Then you just switch. This one is a S, this one is a P, another one SP. Okay, if you ask me, you want to using P first, can or not? Actually, it's no problem. Okay, you put the VP at the top, S you at the bottom. So N you also must be switched, NP over NS. Okay, so this one is the first formula for the transformer, number of turn and voltage. Okay, now we need to see the, okay, another page is it? We're going to check another page. Okay, we got one example question. Okay, we're going to see the question. Okay, example 1. Okay, everyone going to see the example 1. Okay, now you see the example 1. So everyone got paper. Okay, now the number of the turn in the primary coil, okay, and the secondary coil of the transformer are 50 and 250. So we need to write the info first. Okay, so the question now they tell you 50 and 250, then you need to find out 50 whose one, 250 siapa punya. Okay, so we go to label. 50 is for the, okay, primary. So we just write the number of turn for the primary. Okay, so this one is for the secondary. Okay, then after that, what is the output voltage? Now the question, they want to know the output voltage. Output means secondary lah. So they do know how many. Then the info, some more they give you supply. Can you see the word supply? Supply means primary already. So Vp will equal to the 12. So now we need to do the calculation to find what is the Vs. So from here, let's see the Vs. Okay, we're using the formula. Normally, the value you want to find, we put at the top, the first one. So Vs over Vp equal Ns over Np. So what you want to find? Vs. So we just apply all the thing in, then be straightforward to get the answer. That's a 60 volt. Okay, 60 volt. Okay, just a simple question. Then we go to the example 2. Example 2, they go show about the diagram. Okay, let's see the diagram. 12 volt, 36 watt. Okay, this one is for the bulb. Bulb normally is the output. Okay, this one sure is a primary because they got battery, or you say power supply. Okay, cannot say battery. Battery is a direct current. This one's a power supply, alternating current. Okay, now they say number of turn of the primary, Np equal 500. Okay, what's the number of turn of the secondary? Mean they want to find Ns. Okay, so we just apply. Okay, Ns is it. So we put Vs first lah. Vs over Vp. Okay, equal Ns over Np. So Vs is how many? Vs secondary, this one. 12 over 240. Multiply your NP. NP is a 500. Okay, so from here I find it the NS, how many turns? I get it as a 25 turns. The unit is a turns now. Okay, so this one is the answer. I think there's no problem also. Okay, after that we need to find is the efficiency. We think so many efficiency we learned before. Okay, Form 4 we learn efficiency, then Form 5 we also learn efficiency. So this one is the last part we learn about the efficiency. Okay, it's the efficiency of the transformer. Normally everybody also know efficiency cannot more than the 100%. Maximum you can get is 100% only. So from here we create the formula must be output at the top. Okay, output at the top means the output always will less than the input. So you get the answer sure less than 100%, or you ngam 100%. Okay, so from here we create the formula is PO over PI multiply 100%. Okay, for this situation, the question they never say power how many. They let you to do the calculation. Okay, remember output sure secondary. So we can create the formula. P actually equal to VI, is it? So we can put it VS secondary voltage multiply current, that's a I secondary, then over VI primary, then multiply 100%. Okay, let's try the example 3. Okay, let's see the info. The figure they show the 12 volt 48 watt. This one is the output. Okay, this one is a VS. Okay, this one power lah. Later we're going to see you're using power or not. This one NS. They show the NS 200. Okay, this one they provide the current. This current is a I primary. So this one is V primary. So this one is what info they show you. Okay, now we see what they want. Okay, let's see the question. Number of turn of the primary coil. They want NP. Okay, number 2, the current in the secondary coil, IS. Last one, they want efficiency. So we will need to find the NP. Okay, the info from the diagram. Okay, all got already, so we can straightforward to apply. Okay, NP over NS equal VP over VS. We just apply lah. VP, you know how many? VP is a 240. So we just write MP equal, okay, we straightforward to do 240. Okay, voltage for the secondary, there's a 12 volt. Okay, and S is how many? Secondary number of turn is 200. Okay, so from here we get the answer here, 4,000 turns. Okay, we check this one is a step up or step down. Okay, 4,000 turn. Okay, input is how many? 200 only. So this one is a step up. You can check number of turn. You also can check the voltage. Then you know this one is step up or step down. So this one is the answer for the A. Then we need to go is for the B lah, secondary current. Okay, secondary current we can find by using the power. Okay, because P secondary equal to the V secondary, I secondary. So power, we know already from the diagram, there's a 48. Okay, secondary voltage is how many? 12 only. Okay, then the current we don't know. So from here, you find the current is, okay, I get it, that's a 4 ampere. Okay, 4 ampere. So now we go to the last part. Last part is the efficiency. So efficiency is the power output over power input multiply 100%, is it? So we need to find out the power output. Okay, power output we know already, the question get it, 48. Okay, power input how many? Power input, you will see the voltage is how many? Then the question already provide current. So you take 240 multiply 0.3. That one is your power input multiply 100%. So finally I get it. The answer is 66.67%. So this one is efficiency with how to count it. Okay. So from here, if no problem, then we need to continue to the ideal transformer. Just now I told you what is the ideal transformer. Okay, let's see the definition for ideal transformer. Excuse me. Okay, ideal transformer means output power equal input power. So that means if I give you 100% from the input, then your output also get 100%. So this one we say efficiency perfect, is it? So this one we call ideal transformer. Okay, they never lost anything. So they say no energy loss during the process of transforming for the voltage. Efficiency 100%. So this situation we call ideal transformer. So when you read the question, you must be very careful. When they say ideal transformer, then you understood. So from here we write by words. Power primary equal power secondary. Or you can say power input equal power output. So I can create this formula. Okay, so just now I told you V and I inversely proportional. So the equation cannot become the same. So if I want to create the equation, so Vp over the Vs. Okay, I pull the S down. Another side should be Is over the Ip. So this one is the equation. Okay, when there's using the ideal transformer. Okay, now we combine all the equation what we learned. Okay, before that we learned about Vp over Vs equal to the Np over Ns, is it? Okay, now you add one more. When related with the ideal transformer, that should be Is over Ip. So this one is a 3 equation, okay, related for the ideal transformer. This before the V and N we can using for normal one. When ideal transformer we add one more, we add the current in the formula. Okay, now we want to see the another diagram. I show you the diagram. Wait, I go to find out the diagram first. Okay, this one. Okay, can you see this one diagram? There's a transformer. They show the turns. Okay, I make it at the center. Okay, let's see here. Okay, don't bother the line. Okay, let's see the first part. Okay, if I say this one is an ideal transformer. If I say ideal transformer okay, so 240, I give you the power first. Okay, I told you this one power, this one current. I tell you the current Current is 2 ampere. So it's current 2 ampere. This one power should be 240 multiply with the 2, is it? So become 480 watt. Okay, power primary. So ideal transformer. Okay, so that means the output PO also must be 480W. Agree? So now, how many current? So if I say 480 easy, so that means 12 must be times 40. They become 480, is it? So that means, can you see the current here is how many? 480. Sorry, not 480. There's a 40. Okay, I go to play first. There's a 40. Okay, the current here become 40. Okay, one of the questions here we ask, is it ideal transformer? The voltage for the 2 coil, primary and secondary coil, must be same. The answer is no. Voltage for primary equal voltage secondary. The answer is no. Although there's an ideal transformer. Okay, IP equal IS. The answer also no. Okay, PO, PP, put P, equal PS. Yes, this one is correct. This one is the ideal transformer. Okay, V and I not exactly is the same. You can say same. Okay, you also can say different. Okay, because V and I, P equal V and I, one up, another one can be down. So you can adjust, but the P must be constant. Okay, so this one is one of the questions that will test you. Okay, ideal transformer, the voltage primary 20. How about the secondary? Is it the answer 20? The answer is no. Okay, if the current changes, the voltage cannot become the same. So this one is one of the questions related with the ideal transformer. Okay, now we continue with the ideal transformer. Got one of the question. Okay, let's see here. Ideal transformer, the question. Okay, let's see here. They show you the step down transformer. Okay, step down. Okay, so from here, the connector 240 volt main power supply. So this one is a VP. Okay, D varies how many watt? 90 of the power. Okay, this one is a VS for your notebook. Okay, now the number of the turn, NS800. Okay, assume transformer is ideal. So we understood that ideal means PI 90, PO also is 90. Okay, now the number of turn in the primary coil. So A, they want to find the number of turn, MP. Okay, the second one, they want to find the IS, secondary current. Okay, last one, they want to find the current in the primary. Okay, we're going to solve the problem. Okay, let's see the A. Okay, number of turn of the primary, MP. So we can create the equation. Okay, we got NS ready. Okay, so VP over the VS. So NS over the MP. So you'll find the answer for your MP is how many? So from here, I get it. The answer from here is MP 6,400 turns. Okay, that's the answer for A. Okay, then we go to the B. B, they ask about the current for the secondary. Okay, current normally related with the power lah. We're using the power equation for secondary. Power output we know 90. Okay, voltage for output is how many? Voltage for the output is 2. It's a 30, is it? Okay, 30. So VI, so 30. Then the I is secondary I. So IS is 90 over 30. The answer is 3 ampere. Okay, then we go to the C. C is a current primary. Current primary, we know the power. Okay, V input is a 240. So this one is an IP. So the IP become 0.375 ampere. Okay, this one is a primary current. Okay, no problem, is it? Then we need to go is the last part lah. I want to show is the last part. Last part is a factor. Okay, let's see the factor. Okay, factor that affected the efficiency and also the way how to improve the efficiency. So we need to know why the transformer will lose energy. Okay, will lose energy, so the efficiency become drop, is it? Then you also need to find out how to reduce the energy loss through the transformer. Okay, let's see the factor. Okay, first one, resistance of the coil. Because you're using number of turn. When you're using number of turn more, that means resistance become high. Agree? Because the length of the wire increase, resistance will be increased. Resistance increase means you need to overcome the resistance, you lost energy. Okay, so from here the energy will lost heat in the coil because, okay, I think this one formula got problem. Not E equal I squared R. Okay, E equal I squared RT. Okay, that means power equal I squared R. Okay, energy we lost. Okay, you can see the resistance. Resistance is directly proportional with the energy. So that means when your resistance become high, then after that your lost energy also be increased. So we're going to see how we go to minimize. Okay, first part, you can say you're using the type of the wire, copper wire. Okay, why using copper wire? Copper wire is a poor conductor. Okay, poor conductor. Poor conductor, no. You can say good conductor. Poor conductor resistance high already. So we can say this one is a good good conductor. Good for the electricity, there's a good conductor. Okay, good conductor. Good conductor. Okay, there's a conductor, good conductor. Okay, copper wire. First one, we choose the type of the copper wire. Okay, if you choose the aluminium, aluminium is too expensive. Normally we choose the copper wire, good conductor wire. Okay, the next one, you can say about the thick copper wire. Reason why thick? Okay, remember the resistance directly proportional 1 over A. A is the thickness, surface of the cross-sectional area. So this one we call it, when the wire become thicker, resistance become drop. Also another way, we can reduce the resistance. So from here, we cannot say about the length lah, because the length we need to using the longer one, because you want the number of turn more, is it? So from here, the length we just ignore lor. So we need to change is a thicker wire. Okay, we're using the thick copper wire. Good conductor wire resistance is low. Then thick copper wire, the resistance also low because of the thickness of the wire. Okay, this one is the first factor. Now we see the second factor. Okay, second factor, the name we call eddy current in the iron core. Okay, what means of eddy current in the iron core? Okay, now they explain for you. Eddy current means the changing magnetic field. That means I told you just now, because soft iron go, after that they produce a various magnitude and direction, they got changing flux, is it? Changing flux go where? Go to secondary coil. So that means when they do the changing flux, they will lose the energy, they will lose the power. So this one changing magnetic field, we call it eddy current. Okay, eddy current. So from here we're going to see how to solve this problem, eddy current. So they say, first one, they're using laminate. Okay, what means of laminate? Just now the first I show you, laminate means layer. Okay, layer by layer, okay, of the iron core to make the iron core as insulation. Eddy current are not able to flow through the layer of the insulation. Okay, I show you the diagram. See how the magnetic field they will pass through. Okay, let's see the diagram here. Number 9. Okay, this one is a layer, laminate core. This one is a single laminate. Behind is a continuous. Okay, now you see this part. Okay, can you see the turning? The red color turning. That one is a changing magnetic field. Okay, if I using the first one, can you see that one is a whole bar? The big bar. Okay, the big bar, when you want to do the magnetic field, okay, changing magnetic field, you find it, you need to whole bar, you need to changing magnetic field. Then you borrow, go to secondary coil. So that means like this, you need to using more energy, you know. Okay, go to magnetic field changes for the whole object, big object. So from here, this one you find it, you are lost the eddy current so much. So now you see laminate. If I using laminate core means the surface is a iron core. Behind one, they can using the insulation. So from here, when I do the changing magnetic field, I just do one plate only, one plate by one plate. Okay, if the insulation, that means they do the changing magnetic field become less because there's an insulation. Okay, the first one, phase one, that one must be the important because you want the changing magnetic field. So you find it the turning, just small part only. Turning small part means you reduce the current, reduce the energy, be less. So this one is how we go to solve the eddy current. So we're using the laminate iron core. Laminate, from here you can say about the painting. Paint the iron core at the behind one, or you're using the insulation material to create the behind layer. So this one is how to reduce the eddy current. Okay, we can see the diagram again. So they say using the laminate iron core to make the core become insulation. The behind one become insulation. Okay, eddy current cannot able go through the behind one because there's an insulation. So important is the surface part because you want to make it become thicker. Okay, thicker, then the wire can be turned more. Is it? If you're using thinner, the wire how to turn? Okay, so this one is how we go to reduce the eddy current. Okay, now we go through to the third factor. They call it hysteresis. Okay, or somebody say hysteresis lah. So from here we see what means of this one, hysteresis loss. Hysteresis loss means energy. Keep always. You soft iron core, is it? You keep always magnetize, demagnetize, magnetize, demagnetize, the energy will be lost. So this one loss, we call it hysteresis loss. Okay, how to solve this problem? Everybody also know. We're using soft iron core. Okay, because soft iron core, they're easy to magnetize and demagnetize. So they will reduce the energy loss. Okay, so this one can come up for essay. They ask you what type of transformer you want to use and let you to choose. Okay, then the last one, causing by the leakage magnetic flux. Later you need to changing flux, is it? You want to send to the secondary coil, is it? So when you want to send, that means the situation when you send, there will leakage. So electrical energy will lost. Okay, when a fraction of the magnetic flux produced by the primary does not link with the secondary coil because you are further. So before that, I draw. Okay, I show you the transformer. The shape become like this, is it? So this one is a primary. This one is a secondary. When you want to link, you want to send, is it? You want to send, this one got distance. When the distance is further, you find it, there become leakage more. Leakage means the energy loss already. So from here, we need to minimize this situation. So what we do, we winding the secondary and primary coil on the top to each other. Can you see? Top. Okay, we create the transformer now. Is center, we got one of the bar. Okay, we change the shape lah. So center at the top, we join with primary. Then at the bottom, we join with the secondary. So that means when they want to changing the flux, where they change? Center, this part only. So this part, that means you can reduce the leakage of the magnetic field. Okay, so this one is another way how we go to minimize the leakage. So we recall back, because how many factors? First one, resistance. How we solve the resistance? Use a copper wire. That's a good conductor. Another one, thick wire. Okay, can reduce the resistance. Okay, number two, eddy current. How to solve the eddy current? We're using laminate. Okay, we're using the laminate core, iron core. Okay, so this one we can reduce the eddy current loss. Okay, number three is hysteresis loss. So how to reduce this one problem? We're using the soft iron core. What's the reason? They're easy to magnetize and demagnetize. Okay, the next one, leakage of the flux. How to reduce the leakage of the flux? We need to rechange again the shape of the transformer by winding the secondary and primary coil each other at the top. So we can reduce the leakage of the magnetic field. Okay, so this one is 5 of the factor. Okay, I want to show is the leakage one. Let's see the sum leakage diagram. Okay, this one finished. Okay, this part. So this one is drawing. Make sure you know how to draw. Okay, if the question say please design how to reduce the leakage of the magnetic field. So this one is a diagram. So center got one of the bar of the core. After that, this one is the line, the number of turn. This one another number of turn. Okay, so Next one, you can see another diagram. This one also same. Okay, the center got one of the bar. Then after that, they will transfer the magnetic field, become closer. Closer, that means you can reduce the leakage of the energy. Okay, so everyone understand what I'm talking about? Understand or not? Okay, we're going to check attendance first. Okay, attendance today until last one is a VN. Hong Lian, Sivesh, Chen Hong, Kelly, after that Wang Zi, Qing Hui, Melody. Okay, hopefully you all register here. Okay, now I want to ask the question. Okay, you listen so many already. I let you to answer the question. How you answer, you just write in the chat room lah. Okay, question now. 13. Okay. Can you see diagram, is it? Okay. Now you're going to see the diagram I show you. There's one of the question. They ask you the using the appropriate physics concept to explain how would you modify the transformer in 2.4 to increase the efficiency. Increase efficiency. So from here, 10 marks. Okay, we find it how to get 10 marks. First one, type. They want you to say the type and characteristic of the core wire. Okay, this one got 4 marks already. What type? Give me the reason. What characteristic? Give me the reason. Second one, core. Okay, core means the center, this whole bar, steel core or what core. Now they're using steel core. So they ask you, please explain what type you want to use. Okay, after that they say, please give the characteristics some more. Okay, here also is 4 marks. So now 8 marks already. The last part, arrangement of the primary and secondary core. So arrangement, so how you want to susun. Okay, 10 marks. Okay, so from here, I want the question 1 first. You give me the type, you give me the reason, and you give me the characteristic, and you give me the reason. Please write in chat room now. I want to check your answer, is it correct or not. Okay, I will refer here. Okay, please write now. I want to see, is it you just write your name, after that you go to sleep, never follow the lesson. So if you follow the lesson means now you can answer my question. Okay, please type now. Okay, what type you want to use for the wire core? Okay, I'm waiting your answer. Okay, please answer. Just write at the chat room there. I want to check is it correct or not. Okay, Chua Jianing, thick wire, reduce resistance. Okay, correct. Okay, this one is one of the characteristic. Okay, some more type. What type you want to use? Okay, I do want repeat explanation. So Chua Jianing already say about the reduce resistance. Okay, some more. What type? Just now I showed you already the name. What wire we use? Song Ho Boon. Nobody. Okay, come. Jasin, copper wire, good conductor of electricity. Okay, correct. So you say about the good conductor. Okay, another one you just say about the roll resistance. Okay, the next one I want the core. Type and characteristic. Please answer. What type we need to use? What characteristic we need to use? Okay, correct. Also, Hobun, thick wire, reduce resistance. Okay, so if you mention the thick wire, reduce resistance, another one, you change the explanation. Okay, now we second question already. Type and characteristic for the core. Okay, the second question. Then type. Okay, Melody, soft iron core. What's the reason why you choose soft iron core? Okay, use the soft iron core, Jianing. Okay, magnetize and demagnetize easily. So this one is a reason why we choose soft iron core. Okay, another type. Okay, this one is a type. You can say characteristic. Another characteristic. Okay, what's a characteristic? You mentioned the type already. You're using soft iron. Okay, characteristic should be. Okay, correct. Melody. Okay, Hobun. Soft iron, easy magnetize, demagnetize. Okay, so now I want characteristic. Laminate iron core. Okay, or you straightforward lah. Laminate soft iron core also can reduce eddy current. Okay, that's the same thing. So if you say laminate soft iron core, that means you explain two things already. Then you straightforward give two explanation. Easy magnetize, demagnetize, and also reduce eddy current. Okay, last one. Arrangement of the primary and secondary coil. How you go to arrange? How you go to arrange? So mean you got listen just now lesson or not? How you go to arrange? Some go to replay, is it? Go and see what I'm talking about that, is it? Every time just 3 person only. Melody lah, Jianing lah, Hobun lah, and one more Jiasin lah. Then the rest don't know go where already. Jenny lah, don't know go where. Rian mana pergi? And Kelly. Valerie go where? Valerie Ang. How to write the last one? Arrangement. Hello. Last one. Arrangement of primary and secondary coil. Or you want to draw for me? You want to show for me? Okay, Jianing. With the secondary coil and primary coil on the top to each other, decrease the distance between the coil. Yes. That means you can say the primary coil and secondary coil, you make it become closer. So that's why they're widening at the top and also each other top lah. So that one is correct. Yong En. Okay, Yong En widening secondary coil, top each other. Hobun also correct. Okay, Achio. Wow, Achio. You baru muncul, Achio. I want to finish already, or you just come out. Okay, so the answer I will show here. So hopefully you can memorize this question because this one is a hot question. Okay, let's see the answer. Copper wire. Okay, that's a very good conductor. Resistance is very low. Okay, and the next one we're using the thicker wire to reduce the resistance. Then we're using the, sorry, spelling is wrong, not avoid, avoid. Use the laminate core to avoid the eddy current in the core. Okay, then use a soft iron core as magnetize and demagnetize easily to avoid the hysteresis. Okay, last one is widening the secondary coil and the primary coil on the top to each other. Reason is to reduce the leakage of the magnetic flux. Okay, Just now you just give me the aspect, you never give me the explanation. You say the winding each other up and down only, is it? Then you must explain why you want to arrangement like this to reduce the leakage of the magnetic flux. So this one is an essay question. This one we call table form. Okay, hopefully you remember what is a table form. Okay, so I still got the one last page want to show you. Okay, the last page. Okay, I go to open first. Okay, this one. Okay, same as just now what I show you lah. So this one is a conclusion. Eddy current changing the magnetic field, reduce current in the soft iron core. Eddy current will produce and generate the heat. This one is a causes from the eddy current. Then we use a laminate soft iron core. Okay, heat loss. Okay, heat how to loss? As the number of turn increase, the resistance of the conductor that will increase. So heat will produce by electrical energy to oppose the resistance. So how we solve this problem? We're using the low resistance copper wire, or you say thick copper wire. Then the hysteresis. How the hysteresis will lose energy that causes by magnetize and demagnetize alternatively due to the alternating current in the primary coil. Okay, energy will lost as a heat. So how to solve? Use the soft iron core. It's able magnetize and demagnetize easily. Okay, last one is a flux leakage. How come the flux leakage also will be lost energy? Because leakage of the magnetic field in the primary. Because primary will start first. When they want to pass, they will leakage. So how to solve the problem? We go to proper design the coil again. So that means the design means we put center is a one of the coil. Okay. Then after that, secondary coil overlap and won't close to the primary coil. Means the up and down. Okay. We join with the coil to each other. Okay. So this one is the way how to reduce the energy loss for the transformer. So everybody, okay, hopefully you understand what I'm talking about. So now I go through my screen back. Okay, our lesson just until here. So the next homework is your tutorial. So your tutorial, please do the objective. Objective, I think I just show you the answer ABCD only lah. If got problem, you can PM me. Then the structure, I will explain one by one for the coming lesson. So from here, make sure you write the attendance. Okay, so our lesson just until here. So thank you for your watching. Okay, the school will reopen soon. We will see you again. Okay, so everyone, thank you for your watching. Thank you for your sacrifice to wake up earlier. Okay, thank you very much.